All right, well, welcome everyone. My name is Sigal Carmenate, and I'm a transportation planner with Kittleson & Associates, and I currently support District 5 on context classification evaluations. I'll be today's moderator, and I'll push interactive polls throughout today's webinar. I'll field questions for presenters, and I'll help keep the conversation going. Before I introduce today's speakers, I want to share some ground rules, instructions, and other useful information for you. First and foremost, we'd like to thank FDOT District 5 in the Orlando Metro section and Florida chapter of the American Planning Association for co-sponsoring today's webinar. Today's webinar has been registered for 2 AICP certification maintenance credits. After today's webinar, please visit planning.org and look up the event number 9200307 or the event name FDOT Context Classification Webinar to log the certification maintenance credits. For those of you with PE, we will provide professional development hour certificates after today's webinar. Today's webinar will be recorded and shared with FDOT to post on Learning Curve, and we'll also be sharing the roster of FDOT employees who attended today's webinar with the organizational development team for Learning Curve credit reporting. If you're an FDOT employee watching the recording of this webinar and you would like Learning Curve credits, please upload your information to Learning Curve in the External Training tab. We've prepared polls ahead of time, and I will launch these polls throughout the webinar. You can answer the polls by clicking on your response on your screen. All audience members have been muted but can submit questions throughout today's webinar by typing in the questions box. Any unanswered questions will be answered after today's webinar, and it will be emailed to all attendees along with the other handouts. I'll also make a note that there is a handouts tab where you'll be able to download the 3 handouts. Before we dive into today's agenda, I'd like to introduce our presenters. Their full bios and their contact information are in your handouts. Tina Williamson is the FDOT District 5 Growth Management and Complete Streets Coordinator. She oversees all the context classification evaluation processes for the district. Steve Shams previously worked on the context classification evaluations for the district, and he's also the FDOT District 5 RCI and SIS Coordinator. Jane Lim Yap is a planner with Kittleson & Associates. Jane has worked closely with FDOT Central Office on developing the context classification system, and she currently supports District 5 in applying context classification at the project level. We'll also be hearing from Dwayne Carver, FDOT State's Complete Streets Program Manager. He leads Complete Streets implementation across the district, including the use of the context classification system. Finally, we'll hear from Stephen Buck, FDOT's District 5 Roadway Engineering Supervisor. Stephen Buck is the project manager and engineer of record for 10 active design projects and has been applying the new context-based design tools from the FDM. To learn a little bit about your fellow webinar participants, please take a moment to answer the 2 following polling questions. We'll close each poll in about 15 seconds. I'm going to go ahead and launch the first poll here. So our results are in. Seeing most people from FDOT, a lot of people from cities or towns, and then we have a few folks from other organizations. I'm going to now launch the second poll. Okay, so it looks like most folks are actually familiar with the context classification system, and we do have a good amount unfamiliar, and then mostly people have heard about it before or have learned about it in the past. So that's good news for us. Today, you'll be giving an overview of FDOT's context classification system. You'll understand how FDOT assigns context classifications to roadways. You'll learn how context classification fits into other FDOT processes, and you'll hear about key context-based design principles that you can apply to your project work. By the end of this webinar, we hope that you have a stronger understanding of the role that FDOT's context classification system plays in your day-to-day work. Remember that you will be quizzed at the end of today's webinar on 3 new context-based design principles that you learned. To kick things off, Tina will talk about why we have embarked on the Complete Streets initiative and how context-based design relates to Complete Streets.
Okay, can everyone hear me? Okay. Hi everyone, as Sigal said, I'm Tina Williamson, the Growth Management and Complete Streets Coordinator for District 5. Today I'm going to start us off with a brief introduction on why context classification was developed and why it is so important. Next slide, please. Most importantly, safety is the key reason for why we need to tweak our approach to transportation. 2 of the areas in District 5 have been on Transportation for America's Most Dangerous list for several years in a row, and FDOT and our local government partners are working on changing this. Some positive changes that we've made in recent years include targeting 0 fatalities or serious injuries through creating a Vision Zero culture, installing $100 million in LED lighting on state roads to improve visibility, and adopting a ban on texting while driving. Our actions are starting to add up. In 2019, Florida scored among the top 10 states in the League of American Bicyclists 2019 bike-friendly state rankings. However, there's still much work to be done. A key component of our work to improve safety for all users of the roadway involves focused policy and infrastructure investments. Context classification was implemented in 2014 when FDOT launched a statewide initiative to advance complete streets. The FDOT Complete Streets policy requires that we plan, design, and operate facilities to serve all users, and that we need to develop a system of complete streets where each street has a role to play. Meaning, not all streets are the same, and each one should be designed based on its context. Roadway design should promote safety, quality of life, and align with the economic development goals of our partner agencies. So now that we know why it is important, next we're going to look more in depth at FDOT's context classifications and briefly explain how we assign or review the classifications for each state road. The context classification system includes all of the land areas and types found throughout the state of Florida. There are classifications ranging from the most natural wilderness settings to the most populated urbanized areas. Both the context classification and the transportation characteristics of a roadway, such as the types of access it provides and types of trips it serves, inform us about the roadway users' expected demand and the potential challenges and opportunities users experience on the roadway. For example, in the C6 Urban Core context classification, it is anticipated to have more pedestrians, bicyclists, and transit users than in a C2 Rural context classification, and the roadway design should reflect that. Now I'm going to turn the presentation over to Steve Shams to explain the mechanics of how a classification is calculated.
Thank you, Tina. Hello, I'm Steve Shams. I'm the RCI and CIS coordinator for FDOT District 5. I'd like to take a few minutes to explain how context classification is evaluated. The approach to evaluating context classification involves 3 major steps. The first step is to identify any major context changes on the roadway, as this will allow you to determine the major points of segmentation. Next, you will calculate the evaluation measures. And last, you'll compare these measures to the established thresholds and ranges within each context classification. Next slide, please. So what are these evaluation measures? As Tina mentioned, these measures capture the typical characteristics that indicate the variation in development patterns. These are roadway network connectivity, land use and built form, and the intensity of land uses. Next slide, please. These measures are reflected in this matrix. Now, I'm not going to go over the matrix in detail, but I'd like to point out it is included in the context classification cheat sheet that was emailed in advance, and it is also located in the handouts tab of this webinar. Next slide, please. Each district has developed a district-wide existing context classification for all state roads. This GIS database is a preliminary designation developed through a GIS-driven process. Each roadway segment's preliminary classification is reviewed, confirmed, and revised at the beginning of each project phase by FDOT. Next slide, please. Now, you might be wondering, what is the difference between an existing classification and a preliminary classification? Existing context classification considers current conditions as well as permitted developments and program projects. Future context classifications consider all planned future conditions. These designations are provided for qualifying projects or those that require efficient transportation decision-making, or ETDM, such as PD&E projects and larger projects that may require right-of-way. The districts also have the discretion to use future context classification on any project they find appropriate. And now I'd like to welcome Dwayne Carver, who will discuss how context classification influences roadway design and planning. Thank you.
Hi, I'm Dwayne Carver with the Roadway Design Office in Tallahassee with Florida DOT. And thank you for inviting me to come and speak with you today, participate in this workshop. It's terrific that so many folks are learning about context classification and how we're using it to build safer roads here in Florida. Next slide. So we've learned a little bit about sort of where this came from, how we begin to do context classification. What I want to talk a little bit more is why that matters. Here's just one example of one of the ways that we're learning to use a context classification to help us understand what's going on with our roadway system. In the graph that you see here, these colored bars are showing you the number or percentage of total crashes that are taking place on our roadway system based on context class. You can see they go from C1 at the top there down to C6 at the bottom. So, okay, well, that's interesting. It looks like you got a lot of crashes going on there in your C3C conditions. What does that mean exactly? Well, when you look at the gray dots that you see here, those are actually the percentage of roadway miles that are represented as well by those context classifications. So what a graph like this is telling us pretty clearly is that crashes are overrepresented on the roadways that are in those context classifications. On the other hand, if you look down at, for instance, C6 and C5, you see that it's a little more in line. Certainly up in C1 and C2, those are a lot of our roadway, but they're a very small percentage of our crashes. That seems to be working okay. So knowing the context classification can help us understand better what's happening with our data and help us identify, for instance, where we might be having mismatches between what the roadway is supposed to be doing and what it's actually doing, perhaps even in terms of how that roadway is designed. Next slide. Another way we use it, and Tina alluded to this earlier, is that we can tell right away once we've made a context classification designation what kinds of emphasis, modal emphasis we're likely to have on the roadway and what we're looking for there. Knowing that then can help us understand more about how the roadway needs to be designed. Next slide, please. So here are three of the documents that have already begun to incorporate context classification. We're going to talk more quite a bit today about the FDOT Design Manual. We'll also be touching on the Traffic Engineering Manual and the Access Management Guidebook. Now, if you've never used these books, the FDOT Design Manual is what we use to design the roadway itself. Once the roadway is built, it's got to have traffic signals, it's got to have pavement markings, it's got to have intersections. Those things are dealt with in the Traffic Engineering Manual. And then we also may be looking at how the roadway interacts with things along the roadway, driveways, access to businesses and things like that. That's the Access Management Guidebook. So these are three of the documents that have begun to incorporate context classification in the way that we're using it now at the department. Next slide. Okay, thank you. So here's a little quiz. We're not using the quiz software. This is one you can just kind of do on your own. So what you have here is a picture of four segments, four roadways here, and I want you to look and see what the lanes look like, what it looks like along the edges, and assign in your own mind how fast you think these roadways are. If somebody came to you and said, hey, I need a speed limit on each one of these roadways, what speed limit would you assign it based on what you see there? So what do you think is the posted speed in this corridor? I'll give you a few seconds to think about that. And here's a hint. These are all in the same corridor. Okay, next slide. Let's see how we did. All right, you can use the raise your hand function on your control panel there if you guess right for all these speed limits. And what you see is that they're all different speed limits, even though the road is basically the same road as it goes through these different areas. But what happened was in one area, it was a school zone, so the speed had to go down. Another area, it was still a school zone, had to go down even lower. And in between, there may have been some transition areas. But the roadway stayed the same all the way through. And what we find is that drivers don't respond to that very well. They tend to drive the road the way that it was designed. And if you have to use signs to tell them how to slow down, it may not be as effective. Next slide, please. So when we put the when we put the FDOT Design Manual together using context classification, what we're doing now is we're saying, well, for each of these context classifications, what are my different design criteria and how do they need to change? So for instance, if you look just at that top row there that talks about allowable design speed, you'll see that based on the context you're in, you're going to have certain speeds open to you and others are not going to be open to you. So if I'm in a C5 downtown condition, I'm not going to be designing 45, 55 mile an hour roads. On the other hand, if I'm out in the countryside in C1 and C2, yeah, that's where my high speed roads belong. That's where they're going to be. So by knowing where we are in space with the context classification, we can then assign the criteria that's going to make the most sense. You can see other criteria there as well, like lane widths and whether or not there's a left turn lane, whether or not we're expecting to see on-street parking. All these things are covered in the FDM and many more based around context classification. So one of the concepts that we've been able to introduce to this is the concept of something called a target speed, and I won't have to read the slide to you here, but basically the target speed is when everything is all said and done, if you took away the speed limit signs and you just let people drive the way that they wanted to drive, how fast would we want them to be driving? What is the speed we want them to be operating at once the project is done? And that's a function of how they interact with the land around them. So if you see in this slide here, for instance, as in the lower slide there, it says you're supposed to be driving at 35. Well, what's there telling me it's 35? The road looks pretty open to me. I might feel more comfortable driving faster. So if we really want you to drive at 35, if you look at the slide on the right, you can see we've introduced some curvature to the road. There's some things to engage you along the side of the road. We have trees and other places we might have buildings to come up. So we need to make the roadway reflect the speed that you want to, that we want you to be driving. That's the idea behind the target speed. Next slide. We had a problem. If you, I'm sure you memorized that slide I showed you just a minute ago that had the FDM criteria in it. In C4, which is our general urban, we have a really wide range of design speeds between 30 and 45 miles an hour. That actually reflects the range of design speeds that exist today in Florida's general urban areas. And but where you would actually be within that range is a little tougher to tell. So one of the things we're introducing is this target speed subranges to help you understand if you're in a C4, how fast should you be driving? So we have some different ideas here to help you understand that. You see for 30 miles an hour or 35 or 40 to 45, there's different ways that you might want to consider what that speed would be. And the next slide, I think, actually shows that even a little bit better. So here's some questions we might ask if we're thinking about setting target speed on a roadway within this range of potential design speeds. You know, what is the context classification? That's always a good place to start with everything. What is the allowable design speed? That gives you that range. What's the access management class? What's the transportation role of this particular roadway that we're looking at right here? Is this on the edge of town and it's really just moving people in and out of the downtown? Or is it actually in an old neighborhood that has a lot of activity going on along it? How's this roadway functioning there? What's our priority users in there? And finally, what is our safety data tell us about this roadway? Is there a roadway that perhaps needs to be slowed down a little bit? Is there a roadway that's working fine with the speed that it has? Next slide, please. So we have a chapter in the FDM, chapter 202 with speed management, and it has some examples of different types of strategies you can use to achieve these different design speeds. One of the things we found when we created the FDM is that we had gotten really good over the last 100 years at building roads fast, but when it came time to build the roads slow, we had to kind of teach ourselves how to do that. So that's what FDM 202 is designed to do, is to help us figure out what aspects of a roadway want to make it operate at a particular speed. And that's what you would see here in this chapter. And there's some examples here on this slide. Next slide, please. So one of the things that we provide for in complete streets is pedestrians. We have a whole range of users, obviously, in complete streets. And so within the FDM, the pedestrian considerations are also broken out by context classification. We know, for instance, that as our context class gets higher, goes from C1 to C6, we can expect to see more pedestrians on the roadway. So how is that reflected in our criteria? When we go down to sidewalk width, for instance, you can see that the width of the sidewalk actually goes up. And it's not reflected here. I think it's in the little tiny footnote there. But when you're in C4 and C5, if you're actually, there may be a reason to go even to an 8-foot sidewalk if you have a good reason to think that you may have more pedestrians there, or maybe you have some trees included along the sidewalk, things like that. So as the sidewalk goes along, it gets bigger. So, and for bicyclists, we have a similar set of criteria based on context classification. It's actually a lot more complex than this, and we'll, I think, talk about that a little bit later about how the bicycle criteria change based on context classification. But whether or not you can use a bike lane, whether you want to try using a shared use path, that gets into the speed, which is related to context class, and so they kind of all blend together. If you're in an FDOT district, or even if you're not, you should be aware one of the things we introduced last year was the concept of a district bicycle plan. It's not a requirement, it's strongly recommended based on the complexity and sometimes the expense of the new bike facilities that are being introduced at the national level and by FDOT. We need to plan for them a little better than we have. We can't just say it's going to be a bike lane and call it good. So we're actually recommending the districts prepare a district bicycle facilities plan to help them figure out where these more complex types of bike facilities would go. A good example are these separated bicycle facilities that you see here. This is the FHWA's guide that came out a few years ago. We took this information, which is fairly broad, last year, and we pulled out the pieces of it that we knew were a slam dunk could work on the state roadway system, put them in the FDM. There may still be things in here that you'd like to use that are not in the FDM. It doesn't necessarily mean you can't use them. It just means we need to talk about it first. But the stuff that we knew we could use right away, we went ahead and put it in the FDM. You can go out and use it tomorrow. So that's the good thing about that. Another thing that we did last year was we made it possible to take some of the bike lane space, which a lot of folks are finding is not used very much, and put that space into a shared use path within the FDOT right of way. So where we would have had a bike lane and a sidewalk next to each other, we can now combine that into this shared use path here. And so here's an example of a place where you might do something like that. It's mostly intended for our higher speed, more suburban type facilities, but there are other places you might be able to do that. Next slide. Just to touch briefly on some of the other manuals that we have incorporated context classification. Here's an example of one for the FDOT Traffic Engineering Manual. This was something that changed just in the past year. When you want to install a marked crosswalk at a mid-block location, or actually even at an intersection, it used to be that there was a pedestrian volume that you had to account for before you could even go through the analysis process. What we've done now is just said, well, we know that if we're in C2T or C4 or C5 or C6, we know that we're going to have a lot of pedestrians there. So if the speeds are already low enough, 35 or less, we don't need to worry so much about that pedestrian volume. Let's just go ahead and assume that they're there. You have to do the rest of the analysis, but based on context classification, you can just answer that pedestrian volume requirement and go ahead and proceed with the analysis to see if it will work just based on the other parameters. Another example is leading pedestrian interval, which is also allowed in certain context classifications. The access management guide was updated last year. It also has information in there on modal emphasis. So you decide as you're doing access management, if you're doing it more for trucks or more for pedestrians or more for transit, it will affect what kind of access management tools you use. And so we've now incorporated context classification in there as well. Next slide, please. And still to come, this is in the works as a FDOT transit based framework for context classification based framework for transit. And again, based on where you are in space on your context classification, it'll help you figure out what kinds of transit facilities might or might not be appropriate in those locations. Okay. And that gets us down to our next speaker.
Great. Thanks, Dwayne. Hello, everyone. My name is Jane Lim Yap. I'm with Kittles & Associates. So we're going to zoom out a little bit and talk about some higher level principles now that you've seen the policies and regulations and standards that are reflective of context-based design. It's good to really just understand the principles behind this also. Main objective of today's webinar is to deepen our understanding on this principle. So spoiler alert, we will ask you at the end of this webinar on these principles. So as you go through it, you can listen for these principles. So we wanted to talk about our land use and transportation story, as this is key to complete streets. We are excited today to see the participation from both our land use and transportation partners. And so it is a story that really is part of a lot of the evolution of our communities. The story usually starts with this typical cycle, which is here we have a historic village on the lower right, surrounded by farmlands on a 2-lane roadway. A couple of farmers could apply for rezoning and redevelop their farmlands into residential subdivisions. As this happens, the commute between the village area and the new subdivision would lead to higher levels of volume and potentially some congestion on the state roadway. So DOT is called and asked to come and widen the roadway to accommodate this new traffic. After the road is widened, land values along the roadway would increase. A couple more farmers now go and ask for rezoning to potentially commercial land uses. And you'll hear this argument of, DOT just invested in this roadway. We would like to take advantage of this investment by increasing our tax base and converting our ag lands to commercial development. Now the level of congestion is going to further increase, and DOT has to widen the road again. And notice that the historic village now, it may not be as quaint anymore with the context changes around it. So the remaining farmers probably now has a huge economic incentive to sell their land for development. The land values are too high because of access to this 6-lane roadway, and for it to continue as agriculture probably doesn't make too much sense for them. So at the end, we eventually hit this cycle, at the end of the cycle, and this is the road we have. This is familiar to many of us. We see it everywhere. We see that, all of the land uses and development rely on the state arterial for access and mobility, short or long trips, and no parallel roadways were built. We see it everywhere, but this particular example is in Burlington County, New Jersey. So the point of this land use and transportation story is that DOT itself cannot write the next chapter of this story alone. The change in the direction on where we go from here is only possible with collaboration and coordination among a number of entities, including local government, developers, and other agency partners. Overall, Complete Streets is really about linking those transportation and land use decisions that led to the creation of our communities, and we cannot make those decisions in a vacuum. Just as local communities cannot make land use decisions in a vacuum, both of those deeply affect each other, both transportation and land use decisions. So going back to our story, what can be done when we hit this condition where we're built out? This community story is not over and all is not lost. We can think creatively about how to retrofit the network, but nothing can be done without partnerships with the local community and landowners. This slide shows a new collector roadway to the rear of the big parking lots. Although the system is still auto-oriented, we begin to see a better network forming. The parallel roadways provide multiple ways to circulate, spreading the traffic demand over the network. And land use is also part of the solution. So perhaps we extend the idea of the village concept with some mix of land uses, some variations in density and infill development. And this would obviously require serious, land use guidelines and potentially some policy changes, as well as commitment from various partners, including landowners. So Complete Streets is about putting the right street in the right place, but it is also about putting the right place to frame the right street. So this is the first tenet of Complete Street. It's not just about transportation, but it is about land use and transportation together. The second tenet of Complete Streets is about building a system of streets, going from complete streets to thinking about complete networks to complete communities. DOT and our partners can work together to build a system of context-sensitive streets. The roadways that DOT owns or has jurisdiction over, DOT can directly redesign, are part of a broader network of state and local roadways. So no single street can perfectly meet the needs of every user, but over a network of a complete street, the effective network can serve the needs of all users in the community. So speaking of addressing needs for all users, it would be good to ask, who are these users that we're talking about? Well, context-based design asks us to consider the design user, and it varies based on the mode and by the age and ability. If we design for the most vulnerable among the users, we will likely be able to cater to most of the other less vulnerable users. And as all trips start and end with walking or bicycling, I'd like to cover in the next series of slides some context-based design principles that are specific to walking and bicycling. So first, what are the fundamental needs for all users? No matter the mode, the fundamental needs for all users include being safe along the trip, feeling safe, and being able to complete their entire trip safely and comfortably. The design elements that help meet these fundamental needs vary based on the design user. So for instance, people walking and bicycling are sensitive to the details of the environment, including detours, lighting, pavement surface quality, and more. Transit users do not just experience the transit vehicle itself or, when you're inside the bus. We also experience conditions at the transit station and, of course, the last mile connection to our final destinations. So why are walking and bicycling trips so important? And, because they're so important and significant, we can really move the needle if we can influence these trips. Well, it turns out that many of our trips, up to 78% of them, are less than 3 miles and could actually be completed by walking or bicycling if you just think about the distance. But this is not happening. And why? It's because the reason is the right infrastructure is not consistently available to support this travel. So today, although 78% of our trips are 3 miles or less, 70% of those, a subset of those, which are the 1 mile or less trips, are actually made by driving. So when we talk about designing the right infrastructure, what makes a comfortable street? Designing for pedestrians doesn't end at the curb or even at the sidewalk. Pedestrian infrastructure that makes a walkable street include wide sidewalks, typically buffered from the roadway. If the street is in a retail area, zone for dining or outdoor retailing may be there. So, there's a lot of elements beyond just the pavement or the sidewalk itself that really contributes to the walkability of a roadway. And again, of course, this depends on the context, and in a commercial retail area context, some C4, C5, C6 environment, this would be appropriate. We talked about network. So from a network perspective, how do we support walking? Short connected blocks framing a mix of land uses will make it easier for more efficient trips, including walking. So in this example, the street network and land uses on the north side of the roadway are characterized by longer blocks and disconnected land uses. The street network on the south side are characterized by shorter connected blocks and diverse land uses. And this translates to what trips could occur. Trips between land uses on the south side could be much shorter and more efficient for traveling by all modes, including walking. And, this circle shows the half-mile radius in an area, and you can see the greater reach of land uses that could be effectively reached by those shorter trips that we just talked about, versus, in a different pattern and network situation on the north side. So if we have our land uses set up right, we have the network of streets, what other barriers could hinder from a place being walkable? So again, we'd like to engage you on a polling question. What do you think is the top challenge of walkability? Great. So most of you answered presence and absence of pedestrian facilities as a barrier to walkability. Second top answer is vehicle speed. So, and vehicle volume, presence and absence of street trees, all good answers. We think that, vehicle speed is definitely an influence to walkability, and why? It's, mostly a matter of physics, so force equals mass times acceleration, and the faster the speed, the bigger the impact and risk to a pedestrians. So for instance, the likelihood that a pedestrian could survive being struck by a vehicle decreases dramatically if a vehicle is traveling at a higher speed. So that's first. Second top challenge to walkability is, guess what? We think it's also vehicle speed. It's, again, vehicle speed. And why? It's because if we have our land uses set up right, we have a network of streets, we, at 15 to 25 miles, at lower speed, 15 to 20 miles per hour, for instance, drivers are better able to assess their surroundings and identify pedestrians and land uses along the roadway. When traveling at faster speed, this idea of the driver's cone of vision, they're having to focus on a farther distance and likely not focusing on areas around them. So again, pedestrians, someone walking in front of you, is not something that one would be focusing when one is traveling at a faster speed. So what else is a challenge to walkability? If you guess vehicle speed, it's again true. So again, vehicle speed of a roadway influences what we talked about, the land use and transportation relationship earlier. influences the type of land uses that is encouraged along a roadway. Faster speeds, because of that cone of vision idea, will likely encourage destinations that are set back farther from the street, because the idea that you're really the wider cone of vision and you're focusing on a bigger area. So single use and probably set back from the street. So this idea of land uses that would have actually be a destination for walking won't be probably present in a roadway that has fast speeds. So again, it's coming back to that connection between land use. But there is one more challenge to walkability, aside from everything that you all said already. The fourth one, we think, is roadway width. We know that speed-related challenges to walkability are increased as the roadway width increases, and we need to think about walking along the corridor. But when we think about all of our trips requiring us to cross the street, we should also recognize the permeability of a corridor, the crossability of a corridor as an important factor. So motorists driving at higher speeds have much longer stopping sight distance than motorists driving at a lower speed. In this graphic, we show the orange bars as that stopping sight distance. So it's the reaction time of the driver and the perception time of the driver of an obstacle that's in front. And combined, the faster speed roadway, you need a longer time to be able to hit the brakes and stop. And so imagine on a two-lane roadway, that yellow bar is representative of the distance, the additional distance for a pedestrian to cross the street and for a driver to detect that there's a pedestrian on the roadway. And this represents, in this graphic, a two-lane roadway. So if you think about a wider roadway, that yellow bar will actually be longer. So, the need to have that ability to detect a pedestrian becomes more of an important consideration the wider the street is. So, so now I'd like to turn it over to Stephen to share more about context-based design, about how these principles could be applied and examples of how we've applied these principles to some recent DOT projects.
Perfect. Afternoon, everybody. So along with considering the speed and width of roadways, it's also important that we pay close attention to areas where we have a lot of high potential for conflicts, like at intersections, right? Where we have a lot of vehicular and pedestrians coming together in one singular location. This is where we see the highest incidence of ped and cyclist injuries. So intersection designs that follow the 5 principles that we kind of have on the screen here, they provide a safer and more comfortable environment for roadway users. So moving from left to right, we want to make sure that our intersections are as compact as possible. And a lot of times people think that they need large intersections to be able to move either a large amount of vehicles or larger size vehicles. And that's not always true. And so there's ways that we can really shrink down those intersection types and introduce new elements into those intersections to at least make them appear smaller. And that's really going to help us when it comes to managing our speeds and removing that excessive space that's not necessarily needed and that could lead to driver error. So then in urban context classifications, intersections exist in a grid. So if one intersection is congested, we need to make sure people are seeking alternative circulation in the network before simply widening out or improving that intersection. And then integrating time and space. Signal retiming offers a lot of opportunities to minimize wait time for everyone who's using the signal, whether or not you're doing shorter signal cycles or shorter crossings, shared green times. We have a lot of options whenever we start integrating these signals in with each other. And then obviously shared access across all modes. That one's kind of where we're making sure that the pedestrians have crosswalks that they can go through. The cyclists have a method to be able to safely go through the intersection. And then obviously the vehicles, we can still maintain that movement through the intersection. Maybe not necessarily at the speed that they were originally going through, but in a safe and comfortable manner. And then one of my favorites is actually better defining the excess space. There's a lot of extra room that you don't always realize is extra room out there, and that's something we're going to explore here in just a few minutes. But recognizing that is the first step, is that this space doesn't actually need to be here, and it's going to widen my view shed and make me feel as a driver that I could drive faster through this intersection than I really need to be and than I should be. So next we're going to move on to design vehicle versus control vehicle. And this is really one of the most exciting things that have come out of the Complete Streets initiative, at least for me as an engineer. So a design vehicle is someone who is a frequent user of a given street, right? Your daily basis, we're driving through this particular intersection or street. It's going to dictate the minimum turning radius. So if I want to make a turn at an intersection, I need to make sure that my design vehicle can make that turn from the lane that they're driving in into the immediate turn lane, right? So I should be able to turn into the receiving lane that's nearest to me. A control vehicle, though, they don't necessarily need to turn into the nearest lane. They may be, if it's a 4-lane road you're turning down, maybe they go into the inside lane a little bit in order to make that turn. Maybe what you're able to do is like this truck that you're seeing here on the right-hand side, maybe you enter the opposing lanes. The important thing to remember with a control vehicle is it's a vehicle that may be visiting or making this turn once a day, twice a day. There's going to be a different threshold depending on the site-specific constraints and what your origin destination points are for that control vehicle. So it's just some of those things that you need to keep in mind. This is the outcome, though, what you're seeing right here, this curb radius. So the lighter concrete that you're seeing, that's the concrete that we were able to add to this intersection because we actually designed it for the control vehicle in a smaller design vehicle. So we were able to really shrink up the radial return. That leads to slower turning vehicle speeds. It significantly reduces the crossing distance for pedestrians, and it's going to add to the visibility of the pedestrians. So if you'll go to the next slide, the image on the right talks about visibility of the pedestrians. With these bump outs that we've provided and really tightened up that radial return that you're seeing there, you're moving the pedestrian, in this case, about 10 to 12 feet further out into the view shed of the oncoming cars. If you can imagine where that gray car is parked right now, if that was a big box truck, the cars coming at you on the page, they wouldn't necessarily see a pedestrian, right? If they were back further where the sign is. Now that we've moved them out, there's a lot easier line of sight for them to be able to see, recognize that pedestrian. They should be coming to a stop anyways, but hopefully make sure they definitely come to a stop, recognize and yield to that pedestrian. The image on the left is showing what you can do for compact intersections and making sure you add that space. All of this originally was just, I believe, gored out pavement, added in the curbing, added in the landscaping that you see there and the extra tables, and it's almost like a pop-up event kind of approach. But that's something where you add that excess, you address that excess space, and you add these features. It's going to reduce the speeds through this area. I wouldn't drive that fast next to that raised planter, at least. So there's a range of other treatments and tools that can be used to improve walkability at intersections, including traffic operation solutions. These include locating crosswalks appropriately and adding lighting appropriate for non-motorized modes, facilitating two-stage roadway crossings with pedestrian median islands, right? Emphasizing crossings with overhead and in-street signs, facilitating user-actuated crossings with hybrid beacons, giving non-motorized users a head start at intersections with leading pedestrian intervals. And with leading pedestrian intervals, it used to be where you had to have a study if you wanted to add that to a signal operation. That's no longer the case. If you're in a C4, C5, or C6 context, we're able to add that in there without a study. So this is a perfect example of how big intersections can work for everyone. This is a large intersection that has a lot of features that have been added to it to make it to reduce your view shed and make it a lot more friendly for all modes of traffic. So we're going to do an interactive activity. It shows, again, this is an example of a large intersection's been modified, right? Take a couple of minutes and try to see if you can find 3 design elements that make this big intersection work for all roadway users. You can see here that we've reduced the radial returns. You can see that where it says tight corners there. We pre-time the signals. They have clear demarcation of space, right? We have in that case, that's almost like a hardened center line that's shown right there. That's making it very clear where people should and should not be. We have the refuge islands there for pedestrians who are crossing the roadway, and we've created shorter crossings by integrating all of these things in together. So in addition to designing streets to foster short walking trips, FDOT can redesign streets to encourage slightly longer trips that are occurring in our daily lives to be made by bicycling. So today, almost 70% of people are interested in riding a bike. However, the majority do not choose to bike for transportation because different types of cyclists have different needs and perceptions, right? So an increasing proportion of potential cyclists will feel safe and comfortable biking as the amount of separation from traffic increases. And that's kind of shown in this graph here that you're seeing. The more separation that you have from the traffic, the more likely you are to see a different use of a different group of cyclists. So remember, the fundamental needs of all transportation users includes feeling safe, being safe, and being able to complete an entire trip from start to finish safely and comfortably. For cyclists, the design of bike facilities strongly influence their perceptions of the safety and comfort of cycling, right? So for instance, the largest user group in the 4 categories of cyclists, the interested but concerned group, they actually prefer separated bike lanes. So as outlined in the upcoming revisions in the ASTO Guide for Development of Bike Facilities, if you have a facility on a higher speed and higher volume street, you're going to need a greater level of separation and protection in order for those cyclists to feel safe, be safe, and be able to complete the trip comfortably, right? To kind of meet those metrics. So when thinking about implementing a bike lane within your existing right-of-way, consider opportunities to implement buffered bicycle lanes. Okay, in addition to increasing the passing distance between the vehicles and cyclists, they offer other safety benefits. A key safety benefit that they offer is realized at intersections. This is where buffered bike lanes increase cyclist visibility to turning cars, as shown here in these exhibits, right? So you have the sight lines that you're looking at from a vehicular standpoint whenever you're making that turn. That's critical, especially when you're looking at unsignalized streets. So intersections that also at intersections that permit right turn on red, at driveways, anywhere that you have a complex signal operations in place, basically everywhere where you're making a turn, you're going to have that sight line be a key factor in making sure that the cyclist is seen by the driver. So separated bike lanes, like shown here, they offer another degree of separation from traffic. It's an exclusive facility for bicyclists that is located within or directly adjacent to the roadway. It's physically separated with some type of vertical element. So separated bike lanes are differentiated from standard or buffered bike lanes by this vertical element that we introduce into the typical. They are differentiated from shared use paths by their more proximate relationship to the adjacent roadway. So they're usually adjacent to the actual traffic lane. They just have that vertical element introduced there. So these separated bike lanes, they can really have the best of both worlds, right? They have similar geometries of bike lanes, but they're fully separated just like shared use paths. So interest in these type of bike lanes, these separated bike lanes, is growing in Florida. District 7 has one. Another is proposed on Robinson Street here in the Orlando area. This image shows the Cass Avenue separated bike lane in Tampa. I actually have a project right now that's contemplating separated bike lanes. It's definitely something that is getting a lot of traction, and it's something that the DOT is seeing as something we can incorporate into our projects without increasing the typical section by a large amount. So this is an example of a context-based design in action. This is my project, State Road 430 in Daytona Beach. It's also called Oak Ridge Boulevard. It's a half-mile stretch of road that's between the intercoastal and the Atlantic Ocean. So this was actually a 3R project, and when we went to the field to review the conditions, we realized there was a lot of complete streets elements and context-based design that we could introduce into this 3R project without increasing the cost at all. So we actually ended up doing a lane elimination from 3 lanes down to 2 lanes and adding in a buffered bike lane. So now we're going to show you a video. So this is a video that we created so we could explain the vision to the locals and get buy-in. So what this video is going to show is originally these 3 lanes here, they continued forward. Now we have the leftmost lane dedicated as a left-only lane, and we've introduced a horizontal deflection at this initial intersection right here. So you can see if I'm looking forward in this lane, I'm actually looking at the sidewalk, but now we have a horizontal deflection to shift over half a lane, and then we have another curve that we've introduced. In addition, what we've done is there was 40 feet of pavement out here originally. We've reduced that down to 33 feet. And we've done that by shifting in the curb line. If you'll notice on the right-hand side, some of the curb lines may look a little odd, and that in this picture right here in the bottom right, oh, it moved on me. You'll have a little bit of a curved island. We didn't mess with the drainage at all. We just inserted flumes to maintain the existing drainage, which really kept our costs down. We didn't impact any utility owners. It was a lot cleaner and easier to do the design this way. And so another thing you're going to see that we really are proud of is a bike ramp. So the bike lane originally had ended at A1A. So what we decided to do is we created a bike ramp to be able to give those cyclists an option, whether you want to take the lane or whether you want to get onto a sidewalk that we widened out to 8 feet because of that bike ped interaction. You'll also notice landscaping along the entire length of the project. As long as it's a function of the design, DOT can add landscaping into a design project. So as part of the speed reduction that we did in this project from 40 miles per hour down to 35 miles per hour, we integrated landscaping into the design, and that allowed us to pull in those vertical elements closer to the roadway to impact the speed of the vehicles traveling through. So we reduced the width of the roadway. Originally, they were, I believe, 14-foot lanes. We narrowed those down to 11-foot lanes. We eliminated one of the lanes completely and reallocated that space to a buffered bike lane, which is going to introduce some more friction. We added in the landscaping, all those elements together. You really need them all to tie in together to be a useful and functional part of your speed management, which is how we were able to reduce the speed on the roadway. So as we wrap up, we'd like to hear from you about a context-based design principle that was new to you, surprised you, or that you think could apply to a project that you were working on today. So please take a minute, if you guys will, and enter one of the 3 context-based design principles into the question box. And from that, I will turn it over to Tina.
Thank you, Stephen. The key takeaways that we want to leave you with today is that it is all about the safety of all users and identifying those users based on the network connectivity, the land uses, and how those uses relate to the street. You can also use those same measures to work backwards and make conscious decisions about land use and land development code regulations to implement local visions for an area. And we also learned how context classification fits into other FDOT processes and shared a series of context-based design principles that you can apply to your own work. Not every design principle can be applied to every roadway, but we can use context classification to understand who the users are along each roadway and their needs and challenges, and we can begin to design the right context-based solution for each street. And now we're going to take a couple minutes and answer some of the questions that we have received.
Hey, so we have a few questions. It looks like you've already tackled most of them by typing in a response, but was there one that you think could be beneficial for the group to hear?
We have some questions about some of the criteria. There's some folks who are concerned about the FDM shows, for instance, that you can go down to 10-foot lanes in some conditions, and there are some concerns about, well, aren't some vehicles, difficult to operate with 10-foot lanes, which is true. Transit is the example of that. And so within the FDM, you have to also look at the footnotes that go with the tables. And so there's a section that says the lanes are 10 feet, but then the footnotes underneath talk about if you're trying to accommodate buses, you may need a larger lane, 11 or 12 feet, based on the vehicle that you're trying to work with. Same kind of thing. If it's an area that has, over 10% trucks, you wouldn't use a 10-foot lane. So we have tried to accommodate some of those things in the FDM.
Okay, so to wrap us up, thank you for attending today's webinar. As was previously stated, we'll email the responses out to all the questions asked today. So if we didn't get your question, don't worry. And you can also respond to that email with additional questions if you have any. Don't forget that there are links to the frequently asked questions and the context-based design guidance cheat sheet, and we'll also be emailing those out along with a copy of this presentation. And we look forward to seeing how you incorporate context classification into your future projects. I want to thank all of our speakers today, too.
Thank you.
Thank you.
Thanks, everyone.
All right, everyone. Thank you.
Excited to see context classification and complete streets being applied to all projects. Have a great rest of the day.